These alterations in histone structure, in histone charge, come with no change in DNA sequence, but can have a huge impact on expression. They come from the chromatin structure, because the chromatin structure is altered depending on the charge and the sequence of the histones. That chromatin structure determines expression, and expression can in turn be passed on to progeny, both cellular and organismal. Interestingly, changes in chromatin structure that involve histone modification can also be reversed over time. So you can see differences in after transcription, where you may have histone removal and replacement, or you can see differences after replication and the reassembly of nucleosomes. And any of those changes can have impacts on expression. Interestingly, these histone modifications and differences in assembly can be passed through multiple generations of cells or organisms, and they provide a way in which the expression of proteins can be altered without DNA sequence change. This is termed epigenetic inheritance, and epigenetic meaning above, around, on top of, besides, outside, in other words, the genetics, the DNA sequence. This term suggests that these are changes that are in addition to the DNA sequence information rather than part of the DNA. And there are some videos that are in your supplementary materials list that you can watch related to epigenetic changes. And we'll talk in a minute about an example of centromere proteins that can select sites for centromere formation during cell division